Hey everyone, in this video we're going to be talking about one-to-one functions, and in the very next video we're going to talk about inverse functions. So for now we're going to be determining whether a function is in fact one-to-one. So a function is considered a one-to-one function if any two different x's in the domain, so the inputs, they have to correspond to two different outputs in the range. So if you have two x's and you plug them into your function, they're not going to equal the same y value because each x produces a new y value. So one x gives you one y and a different x gives you a different y value, and so on. And this is what's considered a one-to-one function. Each item in the range, each output, comes from exactly one input in the domain. Alright, so here's some illustrations for different situations. This first one is a one-to-one function. So this is what we're going to be looking for in this video. So we want functions that when I plug something in from the domain into my function, then it gives me exactly one y value, and then if I plug in something else, it gives me a different y value, and so on. This one is not a one-to-one function. So this is still a function, but it's not one-to-one. Because notice this x value and this x value, if you plug them into your function, let's say the function is f, they both give you the same y value. Okay, so it's still a function, but it's not a one-to-one function. So we are not interested in that for this situation. What we're looking for, one-to-one functions. And this last one, this is not even a function. So notice I plug in one input and I get two outputs. This is not functioning. Think of a vending machine. This would be broken if you put in your money and got two snacks. So this is not even a function, so we don't want that one at all. Okay, so let's start by determining whether a function is one-to-one. The first one here is a real-life situation. So for the following function, the domain is going to be the ages of 5 males, and the range is their HDL cholesterol scores. So the domain is the inputs into the function, and then the function is telling us the outputs, which is their scores of cholesterol. Okay, so notice we have the ages here and then the corresponding scores for their cholesterol. And this is not a one-to-one function. If you notice, this person was age 41, had a cholesterol of 35, and the person with age 53 had the same cholesterol score. And so this is not a one-to-one function. Each input didn't correspond to exactly one output. How about this one? So this time it's a set of ordered pairs. And so let's go ahead and draw this to help you see it more visual. So we have -3 in the domain corresponds to 5 in the range. Okay, that's the first ordered pair. Then -2 corresponds to 3, then -1 produces 1, 0 produces -1, and 2 produces -3. Notice none of these y values repeated, so we didn't have anything going on where we had one input, two different inputs producing the same output. So this is a one-to-one function. Each input gave us exactly one different output. Okay, so now we have what's called a horizontal line test. And this test, it's a test that tells you if a function is in fact one-to-one. Okay, so this is what it looks like. It pretty much says if I draw any horizontal line and if it intersects my graph in at most one point, which means not at all or once, then it's a one-to-one function. So this one fails because notice this horizontal line hits this function twice. So this graph would not be a one-to-one function. Okay, so quick reminder, we had a test in the past called the vertical line test, and I just want to remind you the difference on that one. So the vertical line test was a test to tell you whether or not a function was a relation was a function. So this one tells us if a relation, so the graph that we're looking at, the relation on the graph is a function. Okay, so that's the vertical line test. So the horizontal line test tells us if the function is 1 to 1 or not. Okay, so if it passes the horizontal line test, it's 1 to 1. So for each of these functions, let's go ahead and graph them to figure out if they're 1 to 1. Okay, so this first one, f of x equals x to the 6th, that's this graph here. If you graph this, you're going to get x to the 6th is going to give you this graph. And if you draw any horizontal line through it, pretty much until if you draw this one, okay, this one only hits once right there, but anything above that, you're going to hit twice. So this fails the horizontal line test. So this function is not 1 to 1. So this is not a 1 to 1 function, x to the 6th. Okay, x to the 5th, let's graph that one. So this is the graph of x to the 5th, and notice any horizontal line that we decide to draw, it's going to pass the test. Now I want to just kind of zoom in on this part here for you. If you graph this on a graphing utility and you zoom in here, this is still going to pass the horizontal line test. I know it doesn't quite look like it only hits once, but let me show you. Let me take you to a graphing website to show you that this doesn't hit more than once. It only touches once. Okay, so here's the graph of x to the 5th, and what I'm trying to have you see is that even if you draw a horizontal line at 0, so y equals 0, it's really not touching more than once. So we'll just zoom in a little bit, but like if you notice, we'll just kind of focus right here. Watch what happens if I get closer. It looked like it was touching where my arrow was, and it's not. Okay, and if I keep going and zooming more, like right here, it looks like it's touching where my arrow is, and watch what happens if I keep zooming. It's really not. And you can keep doing that and see that it's not touching the function more than once. So even though it looks like it, if you keep zooming in, you'll see that it doesn't actually touch the graph more than once, so it does pass the horizontal line test. So this one is, in fact, a 1 to 1 function. Just a quick theorem, and it kind of relates to the last graph we just saw. A function that is increasing is 1 to 1, and a function that's decreasing is 1 to 1. That's because if you graph both of those functions, let's go ahead and just draw them really quick, you'll see what I'm talking about. So an increasing function goes up to the right at all times. So it could do something like this, it could do anything else in the middle here like that, but it's going up to the right, so this would pass the horizontal line test. Same thing with a decreasing function, it goes down to the right, so it could be doing something like this, and it's going down to the right, but that's going to pass the horizontal line test as well. So that is a 1 to 1 function, both of those situations. Okay, so that's it on our background for 1 to 1 functions, and so that's going to help us get ready for what's coming next, which is inverse functions. So we want to know about 1 to 1 functions because they're going to help us find what are called inverse functions, which are the opposite of an original function. Okay, see you in the next one.